Find the distance between the points. When you take a general set of ordered pairs, x1, y1, that's your first ordered pair, x2, y2, that is your second ordered pair. The distance formula is really just spawned from Pythagorean theorem. In class, I went over a diagram of how to find the distance between the two shorter sides and apply that to where you find the length of the hypotenuse. I'm going to save that on this video where I'm just going to save you some time. This is the distance formula when you're given 2 points in the rectangular coordinate system. You take the second x coordinate minus the first x coordinate. These actually can be done in the other order. Plus, and then you'll square that difference, plus y2 minus y1, and we'll square that difference. Add them up, take the square root, and that will be the distance between two specific points in the rectangular coordinate system. Our first example, we have the point 69 and another point 017. x2 minus x1, that's 0 minus 6. y2 minus y1, that's 17 minus 9. Work in the parentheses first, negative 6, 8. Square each one, that's 36, 64. Add them up, you get 100. Square root of 100 is 10. These 2 points are 10 units apart. In the second example, we have the points 7, 5, and 5, negative 4. x2 minus x1, that's 5 minus 7. y2 minus y1, negative 4 minus 5. Again, start inside the parentheses first. Inside the parentheses, that will be negative 2, negative 9. Negative 2 times itself is 4. Negative 9 times itself is 81. 4 plus 81 is 85. Since that doesn't have an exact square root, you can just leave it square root of 85. That's the exact distance. If you approximated it, it would be a little more than 9. Okay, so now where this ties into Pythagorean theorem is, suppose I have 2 points. One of them is 2, 2, and the other is 5, 6. And I want to know the distance between those 2 points. Well, I can create a right triangle by going directly across from the lower point and directly down from the upper point. So what that will do is if I go straight across, that takes me to 5, 2. If I go straight up, that leads me to 5, 6. Now, if you look at the numbers or just count on the grid, that's a horizontal distance of 3, a vertical distance of 4. Now, for Pythagorean theorem, this hypotenuse squared has to equal these 2 leg lengths squared and added together. In other words, a squared plus b squared equals c squared. In our diagram, d squared is equal to 3 squared plus 4 squared. And that's the Pythagorean theorem starting equation. 3 squared is 9, 4 squared is 16. Add these 2 numbers, you get 25. The square root of 25 is 5. And so these lengths satisfy the Pythagorean theorem, and that's true anytime you have a right triangle.